Hello. Today I want to walk through a project I've been working on lately called Anomstack. The idea here is for painless open source anomaly detection for your metrics, and this builds on top of Dagster and a couple of other open source libraries to do orchestration. So basically, the idea here is you define a metric batch, which is basically just you bring your SQL to define your metrics, and a little bit of config to define each metric batch, and then what you get from that then is you get really good anomaly detection on your metrics. So this is like could be business metrics, it could be any metrics really. Typical metrics that you might be measuring as part of your business basically, and you can define your own SQL to do the metrics, or you can also define your own custom Python function. If you want to, if it's not metrics that live in your database, but maybe metrics you want to scrape from somewhere or something like that. So I'll show the easiest way to kind of show this is as an example. So there's some examples here in the repository. But what I'll do is I'll have a look at this GSOD example here to start. And this is basically, this is global surface summary of the day temperature that lives in BigQuery. And this is like a public BigQuery data set that's updated every day. And the idea here is like, this is our data lake. We use BigQuery, say, as an example. Obviously, Anomstack works with like Snowflake, Redshift, whatever other data warehouse you're using. I'm just using BigQuery as an example. And so the idea here is I just define my SQL, which defines the metrics. So in this case, we're filtering for US and UK weather stations. We're doing some joins, and we are deriving some metrics like average US temperature, uh, minimum US temperature. And so the idea here is eventually this gets built up into a metric batch, which is basically we're just kind of concatenating each of these metrics on top of each other. And a metric is basically a metric batch needs to be has a row of each metric batch basically has to have a timestamp, metric name, metric value. So just those three columns, and that's basically what defines a metric batch. So this could be any SQL that you're running on your data warehouse, and as long as it produces a table that has those three columns, and each row is basically one metric, then it'll be ingested into an Anomstack. And so this is how you kind of define your metrics. So you bring your metrics, and then there's a little bit of YAML stuff, configuration here around what database we're using BigQuery, so it'll know to pull the credentials from your environment variable. This is we're writing it into the metrics table. So into the metrics table in the metrics data set, you can write each metric batch to its own table if you want, or you can have one single metrics table, or whatever suits. And just some other stuff around like where's the model. So for each metric, there's going to be a model trained, where those models going to be stored. In this case, we're just using a Google Cloud Storage bucket. And then there's schedules. How often do you want to ingest? How often do you want to train? How often do you want to score? These are just, you define some cron schedules for that basically. And then this bit here is where you're making the link between telling it what the ingest SQL is. So the ingest SQL is the templated GSOD SQL we were just looking at, that right next to it in here in the folder for the metric batch. And so once you've defined this now, Anomstack will kick off four jobs, primarily four jobs. There's like an ingest job, a score job, a train job, an alert job, and then there's a plot job as well. So how this works, how this looks architecturally then is, if you have a quick look in here, we'll see all the moving parts basically in the architecture here. So these are the user inputs we were looking at as an example. And then at the core of it basically is the orchestration, which has been done by Dagster. And there's different jobs. So there's an ingest job, which is just run the SQL, save it into the table, append it on. So this is just getting the metrics in. And there's a train job here, which will basically hit that metrics table, pull in enough training data based on the default parameters, train a model per metric, and then save the models into the model store, which in the previous case was Google Cloud Storage bucket. But it could be a local, it could be a local file system, or it could be S3, or I think we're going to add Azure Blob Storage, all these other places to be added. And then the score job will then pull the latest model and it'll pull the latest model, pull the latest metrics, and then score, get you an anomaly score for each metric as well. And then if that score, there's alert job which will basically look at the recent scores, and if the smoothed recent scores, sort of rolling average of the recent scores, if that's beyond the threshold, then you'll get this alert will trigger an email alert or Slack alert or both, whatever, and that's what you get into your inbox then. So that's a quick overview of the architecture. There's a plot job here which kind of lets you see some plots within Dagster in the logs, so that visualization isn't the core here, but there is a few places where you can actually just look at the metrics and the scores in the output of this plot job. Or there's also a dashboard. There's this little Streamlit dashboard that's running, that can also query each metric batch. I'll give you a quick example here. It is here. Like, it's basically just a very simple Streamlit dashboard where you can look at all your metrics, and in this case these are just like the random BigQuery simple example metrics, which are just random numbers. But you can see they're random, but then sometimes they have an anomaly here. So we can see when we had this dip, the anomaly score went up, and that's kind of what we're expecting. And obviously then your data sources, so it can read from BigQuery, Snowflake, or Python, or whatever, Redshift. We have Redshift here as well. Actually, I just haven't updated the diagram yet. And the end result then is you define this. You can run this in a couple of ways. So you can run this on, obviously you can run it in GitHub Codespace if you want to just play around with it and get familiar with it. It'll just save to a local file system. It'll use a local DuckDB as the database. But really you can run it in Dagster Cloud. It's probably the easiest in a serverless manner. You can obviously point Dagster Cloud at your fork of this repository, and then as you make commits and PRs into the metrics folder, it would just be picked up by Dagster Cloud. Or another option is to run it locally, so you can run it yourself via Docker. So there's Docker Compose up. There's a couple of containers, and or you can also run it in a local Python env as well. So if you want to just run it as like a system service or whatever. So that's a couple of ways to run it. Then adding your own metrics real quick. There's an example here in the repository of a PR that adds. I added these Google Trend metrics recently, and there's a PR example here where you're just basically all you're doing there is just a simple PR to add your. In this case, we're adding the SQL to define, pull from the Google Trends data, do all the SQL, get the metrics, and then just some configuration here for this particular metric batch, like the schedule and the name, basically is the main things. Obviously, then in all the defaults, there is a lot of defaults that you can overwrite. So within the metrics folder, you'll see there's a defaults. Let me see. I'll go back. All of your metrics would live in the metrics folder, and in here there's defaults in here. So for everything you can use any of these defaults, and if they're not defined for each metric batch, it'll fall back to the defaults basically. So you can kind of customize as much as possible, and likewise you can also customize even the pre-processing function itself. There's a default pre-processing function here, which is what pre-processes the data before the training and the scoring. In this case, it's just using it's taking differences and it's smoothing and it's adding lags. But you could define your own pre-process function and tell that metric batch to use that one instead. For instance, that might be if you wanted to use like a pre-processing function that used day of week or time of day type features, you could just define your own one. But the idea is you shouldn't really need to do any of that to get decent enough anomaly detection. You shouldn't have to worry about that, but it's just nice that if you want it, you can. And so the end result then is like you have this running somewhere, and it's going to ingest the metrics and write them back into your database, wherever that may be. And then when things look anomalous, you're going to get these alerts basically, which in this case, there's some real world examples in the anomaly gallery here. But basically it's an email, and the email has kind of like an ASCII art type summary of the data, and then also attached will be a plot here. So like I have an example here of a server from this morning. So this is like a London, the server called London, and this is system RAM, and it's the cached RAM value is what we're monitoring here. And this is just saying that it looked anomalous at this time. And you can see here T0 is the most recent data. So what we have here is like the raw value of the metric, and we have then the anomaly score. Kind of this in this case, it's a smoothed anomaly score because we don't want to just trigger on every spike. We want to smooth it a little bit so we're not too trigger happy. And then this star here is for stuff that's been flagged as anomalous. And so you can kind of see here, this is just like a text way to kind of look at the time series. There's also tags here if you wanted to have different rules. If maybe you wanted to route these batches to a different filter in your email, or tag them differently, that's all in there. And then attached to each alert is the plot of the alert itself. So in this case, we can see like the metric value is always around 3,500. I guess that's probably 3.5 gigabytes or something like that. And we saw it dropped, but a little bit of a peak in the anomaly rate, but actually not sufficient to pass this threshold. The default threshold is 80%, and this is the smoothed score, so it's not just an individual score. That's why there's a little bit of a lag here. You can see when it does eventually drop and then goes back up, it's not until kind of the next timestamp that we have the smoothed score goes up enough to trigger the threshold. These are all parameters you can play with and stuff, but the defaults should generally be useful enough. And so that's the idea here: is we get this email, we look at this plot, and we see, yeah, if there's a drop in RAM, is that something I care about or not? It's up to you. Then you can decide whether you want to take action or not, basically, or just move on. And then so the idea is in your inbox you have now basically a stream of pretty decent anomaly detection based on your metrics coming into your inbox, or whatever system you want to use, Slack or any other tools. So yeah, that's like a really quick overview of what's going on here. The README has a lot more information, and we're basically looking, if you want to help out, we're looking for contributors. We're looking for people to start using this. I've been using it myself. The reason I built this is I've built versions of this probably 5 or 6 times now. I've either built this internally myself in like every job I've been in, or I've also purchased these modern data stack tools that are also kind of useful as well. But really, there's no reason why we shouldn't have a decent anomaly detection system that's easy to sort of self-host or deploy yourself without any major infrastructure overhead or anything like that. This should be basically a solved problem by now. So I kind of got fed up doing this every time I went into maybe looking after business analytics or internal metrics for companies. I decided to just build this tool so that I think it could be something that somebody who's not necessarily a software engineer but actually knows how to write the SQL, knows how to define some of these things. The idea is it lowers the barrier to you to just kind of you define the metrics, do some configuration, and the Anomstack will do the rest. Basically, that's the idea. So yeah, feel free to check it out. Any feedback would be great. Thanks a lot.